Dear students, very good evening, South Asia. Very good morning, New Zealand. A warm welcome to the Astro special discussion series under the Astrobiology and the Paleontology programs of the Eco Astronomy Inc. Let me highlight interesting facts of today's our special person who enrolling with the Astro Week. We are honored to have with us today a distinguished guest, Dr. Siddharth Pandey, hailing from Mumbai, India. Dr. Pandey is a former NASA JPL postdoctoral fellow and leading expert in sample collections technologies of the Mars, Venus, and the icy moon missions with a strong background in hardware development, system engineering, and the project management. He has contributed to the space biology experiment on International Space Stations and the ISRO PS-4 Orbital Platform. Beyond his technical accomplishment, Dr. Pandey has been instrumental in institutions building led as high-altitude mountain expeditions in India. He served as a director and the coordinator of the Protoplanet Private Limited, a Bangalore-based organization dedicated to the advancing climate and space explorations through the training and immersive experience. His remarkable contributions have earned him prestigious accolades, including NASA Ames Technology Transfer Team Awards in 2017, National Space Society Australia Award in 2017, International Astronautical Federation Immigrant Space Leading Award in 2015, and NASA Space Flight Awareness Team Award in 2014. Since 2019, Dr. Pandey has been exceptional supporter member of the Eco Astronomy Inc and playing a huge key roles in advancing astrobiological outreach and education work in South Asian region. Today, he will share in insight on astrobiology and space system designing. We highly encourage all the students actively engaging with these very special sessions, and then you can get asked many questions at the Q&A sessions. With that being said, I would like to invite this talented and the glorious scientist, Dr. Siddharth Pandey, to address Eco Astronomy Inc platform. Dr. Pandey, it's your platform. You can get started.
Thank you so much, Arvind. It has been a few years since we last spoke. Thank you so much for a very warm introduction. It is my pleasure to connect again with Eco Astronomy and talk more about some of the opportunities for the students who are attending today. I see that there are a lot of young students that are part of today's live discussion, and there will be some more students, I think, through your video, which will be recorded, who will get the chance to hear me. So I will share my screen and give a presentation. My name is Siddharth, and I'm currently in Australia, in a place called Perth. Perth is in Western Australia. It's the western part of Australia, and it's one of the most remote cities in the world. We are thousands of kilometers away from any other city, so it's a very remote place very remote part of Australia. And one common thing that we have is we both have the Indian Ocean close to us. So I'm connected with you all through the same ocean, Indian Ocean. So you're above me in the map. You're on the northern side of Indian Ocean, and I'm on the south, the bottom part of Indian Ocean. So very glad to speak to you all. It's time over here is 9:13 a.m. 13 minutes past 9 o'clock, and I think for all of you it's a little over 7:45 or so, 7:45, 8 o'clock, I think, in Sri Lanka. And my personal background has been as an engineer. So I'm an engineer who has been working for the last 12 years alongside scientists. So most of those scientists are biologists. So people who are trying to study biology in space. My job has been to build instruments for them, equipment for them, hardware for them, right? So engineers find out, so scientists ask how and why, and engineers figure out how to do it. So scientists ask the questions, like they frame the questions in space. If they want to figure out, why is space black? Why is Earth round? Why is our planet blue in color mostly? They ask all these questions. Why is the sun yellow in color? Why does it look orange in color when it is setting? And engineers make the instruments, the tools to help them answer those questions. So I work as an engineer to support the scientists who are asking these questions. And over the last 11 to 12 years, I've spent time working in different countries. I'm originally from India. I have done my early studies up until my graduation in India. And then after that, I moved to Europe. I was studying there. I did a master's in Netherlands. And after that, I moved to United States, and I was working at NASA for a few years, where I got a chance to work on different space missions. Some of those missions were going to the International Space Station. Some of you might know that our planet, our Earth, has a space station that is constantly in orbit around it. It's called the International Space Station, and there are astronauts who live on board that station. So they conduct different kinds of experiments on that. So we provided them those experiments to be conducted. We built those experiments, and then they fly in a rocket, take off from Florida in United States, and then they reach the space station, and then they conduct those activities on board. So I have been I've been very lucky to get an opportunity to work alongside some very smart people and learn from them. So the first, I would say, advice is that you should try to surround yourself with very smart people, very knowledgeable people, and then you should try and observe them. You should never be the smartest person in the room. You should always be the dumbest person in the room. So then you are able to absorb all the knowledge, all the information. So it's very important, and you should never feel bad about it. Even if you don't know something, it's absolutely okay. Even now, I walk into meetings and people are talking about some concepts which I don't know much about. So I don't ever feel bad about it. I never feel I don't understand this. Okay. So never feel bad. Always be open to learning about some new concepts. So that was my first lesson that I learned when I went to these places. And the best part was that most of the scientists there, they are very encouraging. So as a young student, they gave me a lot of responsibilities. They gave me an opportunity to ask questions. And when I was there, I realized that just because I don't know something doesn't mean that they're going to make fun of me or they're going to feel that I see in the team. In fact, they encouraged me to learn as much as possible and also gave me opportunities to prove myself, which was something which I felt was very empowering. So it was a great, I think, experience learning from such people. And I worked on different kinds of systems there. I don't want to go into too much detail of what specifically those were, but broadly speaking, there are a lot of robotic missions that are sent to different planets in our solar system. Starting from, of course, our moon, then on to Mars, Venus, and other objects in the solar system. We send these missions to look for life or to look for any signs of life. Whether was there life on Mars? Was there life on Venus? So if you have to answer these questions, it's easier to send robots than to send humans, which is why humans have only gone until the moon. They haven't gone beyond that because it takes a lot of, you need a lot of very heavy spacecraft, big spacecraft to support us, human beings go to these places. So while we are doing that, while we are developing it, we actually send robots. So robotic missions are sent to all these different places, all these different planets. And we as engineers are part of developing the instruments that are part of those missions. So that was kind of my contribution when I was working there. And I also got a chance to work in India to establish a center in astrobiology at University in Mumbai. And I led that center for about 3 years. and it gave me an opportunity to work with a lot of students from age of 20 years, actually from age of 18 years all the way to about 25, 26 years old. And we also conducted some school sessions and interactions with some primary kids and higher senior education kids as well, secondary education kids as well. So currently, I have my current job. I do two jobs. I have a day job, and then I also have my own startup company called Protoplanet, where I'm the director. But in Australia, currently, I'm working for Fugro. So I will just play this small video to give you a idea of what Fugro does.
We are Fugro. We use the power of geodata to unlock the secrets of Earth. From surface to subsurface, from natural to built environment. Together with our partners and clients, we're solving tomorrow's problems today. How? By turning geodata into practical advice for safer, sustainable and efficient design and construction. Our geodata shows the exact composition of the surface and subsurface of virtually any location on Earth and how the environment affects that location. We map the ocean floor and urban areas using our geophysical equipment. This guides our geotechnical investigations, which reveal insights about soil layers. We model the digital subsurface using our gathered geodata, aiding our clients in defining the most suitable construction designs. We monitor real-time data in sensitive environments, ensuring operational efficiency for critical assets. Innovation has been at the heart of Fugro since our founding in 1962. We're still pioneering today and committed to being the most innovative geodata company in the world. What's the real key to our success? Our people. Fugro is home to expertise and talent from over 100 nationalities who are actively part of the push for a sustainable future. We truly believe our work is bigger than each individual project. We aim to contribute to a world where nature is protected and people can thrive. Fugro, unlocking insights from geodata for a safe and livable world.
So before you send any robots to other planets, you actually first try and understand how do you explore parts of our own planet on Earth, whether that is in the deep sea or in the very remote environments. And one of the reasons when I left NASA and I came to Australia and I joined this company called Fugro was that Fugro was deploying a lot of robotic vessels in the deep sea. As you saw in the starting of the video, these vessels were going inside the ocean, as you must have seen at the starting of the video. They are going down and trying to explore, and they are all being controlled from thousands of kilometers away on our planet itself. We are sitting in Earth, and we are remotely controlling these robotic vessels. And the same kind of technology can be used to remotely operate robots in space. So that is why currently we are working on deep sea as well as deep space. So there is a lot of technology that is being used in both the environments, on our planet as well as in space. So that is currently my day job where I work on this concept. And we have a team of about 15 people in Perth, and we are working on space mission operations. So what is meant by space mission operations? So whenever you have to control a spacecraft, when you have to send it, so for example, if you launch it from Earth, it is going towards the moon, for example. This spacecraft on the top left side here, this is a lunar lander. This is developed by a US company called Intuitive Machines, and they have so far done 2 missions where they are trying to land on the surface of the moon. So far, most of the times the missions have been sent by NASA and other space agencies, but now you're also having some companies, private companies, who are sending spacecraft to land on the moon. And Intuitive Machines is one such company which is sending such a spacecraft, as you can see. And this on the right side is an image of the moon, right? So when the spacecraft has launched from Earth, it is in orbit, it is going very high into space, it is going towards the moon. So you normally have a team of people like you're seeing in this photograph over here who are sitting, and they all have different responsibilities, okay? So the spacecraft has different components, it has different systems. There is a engine, there is the power system where you're capturing the solar energy from the sun. You're having the controls of the spacecraft, the orientation, when you move it back, like you have to orient it. And you also have the the thermal and the mechanical systems. So there are a lot of systems inside the spacecraft. So when the spacecraft is going from Earth to the moon, you need a team of people who are constantly tracking the health of the spacecraft. What do I mean by health? So it's just like humans, right? Like our own health is what? We look at temperature, we look at if we have any symptoms, right? All of those kind of things. So similarly, when you're trying to spacecraft, whether it is a healthy spacecraft or it is you can call it like a sick spacecraft. So you normally constantly monitor how all the different subsystems are doing, how is their performance, and in case if you need to make any changes, in case if you need to make any small adjustments in the mission. So all of that requires constantly a team of people on Earth who are managing and remotely monitoring the spacecraft. So that is what our team does. That is what is called operations, where you need to constantly be monitoring it. And in case if there is any problem on board, there are people who are constantly sending up any messages. You must have seen in some movies as well, like some space movies, if you have all seen, like in Martian or even in Interstellar and some other movies, you must have seen that there is a team that is sitting in the ground control, in the mission control, who are talking constantly with the astronauts in space. So right now there are no astronauts in this mission. It is just a robotic mission, but even you have to talk to it, you have to send it data, you have to receive data from it, right? So that is the work which is called operations, and that is what our team does from Perth. This team, as you're seeing in the photograph, is actually current. In this photograph, you will see in the background, if you're noticing, this is not in space. They are originally a team of people who have been remotely operating some ships and submarines, which are also very, very far away from Perth. thousands of kilometers away, there's a robotic, completely uncrewed, like nobody is on board that ship. It is going on its own in the ocean. So they are remotely controlling it. You can see here this person who's having joystick control in this photograph. So it's almost like a video game where they are controlling this underwater submarine, which is connected to the main ship with a cable. So all of these people, very highly trained individuals, and now they are going to be, they are operating, and part of this team is training people who are operating lunar missions or missions that are going to space as well. So that is why it says here, space mission operations from deep sea to deep space. The other part that my job entails, that I have been part of, is that the Australian Space Agency. So Australia has a space agency. Here you can see the logo on the bottom right side. They have a project which our team had supported until early this year, early this year, where they are building a lunar rover. This is the early design of the rover. It is roughly about a 20 kilogram rover. It's not very big. Like you see my screen, it's about this big rover. It's a very small rover, but this is Australia's first mission to the moon. It is called Rover, and hopefully one day Sri Lanka will also have a similar lunar mission going. So hopefully some of you will be part of that mission, flying robots into space. So as part of Australian Space Agency, our team was designing and developing this lunar rover, and we completed our responsibilities and we handed it over back to the Australian Space Agency, and now they are developing it further. So this is something that our team also has expertise in, and some of the work that I had done, it involved working on, we say robots. What do you mean by robot, right? This is a robot. This is a robot which is moving on the surface. So it is a rover, but robot is a general word. Rover is something which is roving. Roving basically means it is having wheels and it is going on the lunar surface. And what is the purpose of this? Why is this being sent on the moon? You can see that there is an arm over here. So this mission was designed to collect some lunar dust, lunar regolith material, the surface material that is there, the soil, and then deposit it at a different location. So it is part of a larger system that was working on the surface, is supposed to be working. And this has not yet reached the moon. It is still under design. The plan is that in 2027, 2028, this mission will be launched and it will reach the moon. And it is reaching the south pole of the moon. So you can see over here, the solar panels are completely vertical. You see how they are completely straight? And the light is coming almost from the horizontal side onto the panels, which means that the sun is very close to the horizon. It is almost like setting, like on Earth, when it is evening, you'll see the sun is right near the horizon. It is very, very low. So on the south pole region of the moon, the sun is always at that altitude. It never goes higher than that. So the solar panel is designed in such a way that it can always get maximum exposure to the sunlight that is coming. So it has to be completely vertical, capture all the light as it is coming from the side. And that is very important because the lunar surface is very, very cold. The temperatures there go down to minus 110, 120 degrees Celsius. So because it is so cold, you want to make sure that your rover is warm so that you can protect its different instruments on the inside. So that is why it is very challenging to land any person or any robot on the surface, because it is a very cold environment. There is no atmosphere on the moon, unlike Earth. And even on Mars, there is a very thin atmosphere, but on the moon, there is no atmosphere. So when you are exposed to the sun, the temperature is very, very high. But in case if you're in the shadow, as you can see here in the background, if you're standing in this shade over here, this is going to be very, very cold. So it's a very extreme temperature environment that you have to design your system for. So our team, and then it has this mast with camera on it as well, because this rover is supposed to navigate itself on the surface. If in case if there is a rock or a crater in front of it, it should be able to identify it and drive around it. So all of these are the different systems that are being tested in this mission. Whether it is the wheels, as you can see, it has very special wheels. It is made out of metal. There is no, like on Earth, you have rubber wheels in your cars and trucks. This is completely made out of metal. And it is having 4 wheels, 2 on each side. It is having all of these different systems that are there. This gold shiny surface that you see is something which is used to keep to reflect all the heat away. So right now I said that it gets very cold, but if you're exposed for too long to the sun, you actually will heat up very fast as well. So you have to make sure that your temperature inside is balanced. It is neither too hot nor too cold. So all of these are the important parts of a spacecraft design that a team of engineers works on. There's a team that is ensuring that the rover is within the temperature limits. There's a team that is ensuring that it is getting enough power from the solar panels. There is a team that ensures that the wheels are working properly. It is not getting stuck. Okay. Then this scoop that you see with an arm on the backside, it has to conduct its own operations. There is a team that is working on the camera. So you see, it's a very big team. We had about 50 people that were designing this whole system to, bring it together. And it all has to fit. This whole rover is within 20 kilograms. So 20 kilograms is not a lot of mass. It has to all fit within that amount of space and weight. So all of these were the important aspects. So this is just to demonstrate to you what does designing a spacecraft mean. You have so many different moving parts, moving objects that you have to keep in mind as you're designing this system. And all of you, in fact, can think of these as design projects as well. We conduct different projects where we give a task to the students that you have to design a mission to go to the surface of Mars, and you only have so much of fuel, you have so much of weight, so much of power. Now, go ahead and tell us the different ways in which you can land on the surface. So these are the kind of different missions that are developed. They are very challenging missions. Even so far, last week you might have read in the news there was a spacecraft in Japan which was supposed to land on the moon, but unfortunately it had a crash landing. It did not land properly on the moon. So it is very challenging even now, even though it has been over 50 years that humans have been sending spacecraft to the moon. It has not been achieved by everyone. It has been very, very challenging for many, many countries. The other I mentioned to you, Intuitive Machines. So this is a photograph from their facility in the United States. So this is what the spacecraft looks like on the top right here. This is their control center in Houston, in Texas. And this is the size of the spacecraft. So if you have a person standing next to it, this is how tall the spacecraft is. And as you can see, this is not a rover, but a lander. So what is the difference between lander and rover? Lander is having like these legs. So once it lands, it cannot move. It is going to remain there stationary. It's not able to move. Sometimes landers have the ability to, there are some rockets there where again it can take off and then hover and then again land in a different location. It can do those kind of things, but it is not meant to travel on the surface of the moon. It is supposed to remain stationary. And then inside this lander, you will have a lot of other instruments. So like, for example, the rover which we had developed for the Australian Space Agency will be fitted in a similar looking spacecraft inside it, and then it will come down from it. There's going to be a ramp, like a slope, and then the rover is going to come out of it, and then it will, go onto the surface. So all of these are the different things that we have been working on while I have been here at Fugro. This is a very detailed slide. Might not go into too much detail for all of you. It will be a little complex, but the main point I want to make to you is that my personal work has been on collecting dust samples, soil samples. How do you go and collect soil samples, and how do you do it in different environments? How do you do it on the moon? How do you do it on Mars? How do you do it in Venus? How do you do it when you're flying around Saturn, around its icy moons? So there are all these different, in our solar system, there are so many different worlds. After you have come out of Earth, you've gone into space, you have all these different environments in our neighborhood, these planets and moons in our own neighborhood, in our solar system neighborhood. And we are developing systems to go and explore all of these places. So whether it is landing on the moon, whether it is landing on Mars, there are different types of challenges that are faced when you're collecting the samples. So I had been involved with designing those systems. The other experience that I developed was developing, I mentioned to you at the start of the talk, the International Space Station. So while I was working at NASA, on the right side, you can see the image of the International Space Station. It's a very big form, stretching from one end to the other. And you can see these are the solar panels that generate enough power, and you can see Earth in the background. So this is a huge, I think it is your American football fields. I think it is that if you put two American football fields together, it is that wide, I think. And it has different modules inside it where astronauts can live. So it's a very big platform within which people are living. And inside there is temperature and pressure is maintained for humans to survive, like to live inside it. There is oxygen and there is proper temperature control, so people can live inside it. So I had developed this small experiment that you're seeing here in this photograph. It looked like this black box sitting in the center. And inside it, we had sent some small containers which had fruit flies. So what are fruit flies? So many of you, when you have kept some fruits, you must have seen in your house when there is a banana, if it is going bad or it is, becoming overripe, you will find that there are these small flies that are flying on top of it. Those flies are called fruit flies. And the objective of why are scientists sending these fruit flies into space is because they are very, you can say, genetically similar to humans. 75% similar to us in terms of the genetic makeup, these fruit flies. And if you have to do experiments to understand how space affects life, you can either do it on humans, but if you have to get more data, collect more information, you have to send, say, 100 humans into space. Okay, so but to send 100 humans into space, you have to send so many more, there is so much more spacecraft that you have to fly, and to support each human you need so much of food, we create so much of waste. But to start with, before we are able to fly 100 humans into space, you can actually send hundreds of flies, because flies are very small. You can fit them inside a box, you can give them the food. So this green color that you're seeing here, it was basically a sugar based agar, like a medium that was prepared, and that was food for the flies. And we had sent two kinds of flies. One was in the top chamber and one was in the lower chamber. And we had a camera system. This is just a photograph to explain what that inside was looking like. So there was a camera. It was looking at this small fly enclosure, and there was a mirror on the side. And this was the view that we were getting from the camera, where we were looking at the two chambers and we were looking at the flies. The main objective was the camera was trying to track how much the flies are moving around inside this box. And we were trying to understand their behavior when the flies were sent to the International Space Station. Because on the International Space Station, the gravity is almost zero. You must have seen astronauts, they are floating around in space. There is no gravity. So the objective of this experiment was to study how does the absence of gravity affect the human body. And to understand that, we were looking at how it affects the fruit flies. So this was basically the small experiment module that we had developed. And it was a good learning experience to understand what happens. And it is very difficult to make something where you have to put any living organism inside it, because they die very fast. Like these small flies were not able to survive. So we had to keep doing, we had to keep modifying our design to come up with the right size of the box to ensure that the flies were not dying out. Similarly, until a few years ago, I was part of developing another mission in India where we were looking at the growth of small plant samples. So I was able to, whatever experience I had from US, I was able to bring it to India when I was working at Amity University. And we developed this mission to fly into space from the Indian rocket. So ISRO, which is the ISRO, Indian Space Research Organization, it is India's NASA, India's space agency. So we worked with them to launch this mission. It launched last year, and they were also able to collect a lot of samples. So that was the first biology mission that took place from India into space, first space biology mission. And since then, now there are about 6 to 7 more experiments that are coming from different institutions that are going to be flying to the International Space Station. And there is an Indian astronaut as well who's going to be flying very soon in the next few days to the International Space Station. His name is Group Captain Shubhanshu Shukla. He's an ISRO astronaut. So ISRO has selected 4 pilots to become the first 4 astronauts of the country after India had its first astronaut in 1984, Wing Commander Rakesh Sharma. And almost after 40 years, India will be sending humans again, astronauts into space, or Vyomanauts as we call them in India. So that is just to tell you a little bit about those experiments that I had done when we were in space. Now let's talk about something much closer to our own planet, our own home. So before we go into space as humans and start walking on the moon, start walking on the surface of Mars, we want to first understand what experiments we want to conduct in those places by visiting places on our own planet. Our own planet is a very interesting place. It has some very, very extreme conditions, environments where you can actually study Mars-like conditions. It's almost like Mars. And these places are called analog environments. So we conduct a lot of analog research and training. So over the last year, in fact, we completed just 1 year yesterday. Protoplanet was a company that we built on almost 8 to 9 years of experience doing this work in India. And the objective of Protoplanet is to train the university, train students, and also train ISRO. Like, we have a lot of ongoing work where we are working closely with the scientists and engineers who are there inside ISRO, because they have not done this kind of work before. For them, this is a very new area. It's a very specific, it's a very niche area, very specific area. So because we have had previous experience, we are closely working with them. And the objective is to provide exploration training and to foster this, you can say, like a connection for people between our planet and the universe. So how do we explore our own planet? How do we conserve our own planet? And how do we use the different locations in our Earth that can be used to explore other places? So that is the ethos behind Protoplanet. We have a tagline: space bound, Earth conscious. So you have to think about space, but at the same time, you have to take care and conserve our own planet. For this, we have been selected last year as an official partner of ISRO, as the space tutor company, where we work with them to conduct education and public outreach in India. So why did we decide to build this? Well, one of the main reasons is that even though India is having a lot of opportunities, generally speaking, but it is very difficult for students to get these opportunities. And this is where we felt that we can help, where we can increase the access to the learning opportunities and training opportunities for thousands of colleges in the country and schools in the country. And there are a lot of missions that ISRO is building, that India is building. So we wanted to develop a program that allowed the student community and the scientist community to work on developing good quality proposals, good instruments, and work very closely with ISRO. So as you might be aware, India has sent a spacecraft to the moon. It has sent 2 spacecraft, actually 3 spacecraft, Chandrayaan 1, 2, and 3. One landed on the moon, soft landed, and there was a rover inside it in 2023. It has sent a spacecraft to Mars called Mars Orbiter Mission, or fondly called Mangalyaan. And it is working on a human mission as well called Gaganyaan, where it is planning to send these astronauts and build a space station called the Bharatiya Antariksh Station, BAS. So there are a lot of these opportunities that we need to utilize. And India is having a diverse range of conditions that are helping us understand Moon and Mars. So for example, we have places in the northern part in the Himalayas, like in Ladakh, which are having this cold, dry environment, arid environment. And the photograph on the left side is a lake where you have a lot of salt deposit, and it is at a very, very high altitude where the oxygen is almost half of what you're breathing and I'm breathing right now. So it is a very, very unique, harsh environment. In the center, you see this green lake, this circular lake. It is actually a crater. So many, many hundreds and thousands of years ago, there was a meteorite that came and did an impact on the Earth. It created this impact crater. There are many craters that the Earth has, but very few of them are so well preserved. And this is one of those locations where we have a very well preserved crater site. And why are these important? It's because when you're exploring Moon, when you're exploring Mars, we're actually looking at where those craters were on those planets, because you have a lot of water that got collected in those craters, especially on Mars. So we are trying to understand how life might have originated inside those craters. So that is why it is very important for us to study them. And similar to craters, another exciting place are caves. So when you go underneath the surface, you find that life is existing even underneath the surface, ground. So we look at limestone caves that are there. And on one of the islands in the Andaman and Nicobar area, there is a volcano on an island. And volcanoes are important because you can see as all the hot gases are coming out, it is creating a very energetic environment. There's so much of energy, chemical, geochemical heat coming out that actually has supported life. There's small microbes that are found living on the slopes of those volcanoes as well. And even inside the deep sea, you can see this hydrothermal vents. So if you go down into the ocean and you reach the sea floor in the ocean, you will find a lot of these hot smoking vents, which are called hydrothermal vents, where a lot of heat is coming out from the sea floor and eventually coming up into the ocean. And around these vents, you will find a lot of life that is living. It could be crabs, it could be different kinds of fishes, it could be small microbes, so many different kinds of life, almost like aliens that are living in our own planet. So we have all these exciting places, but they are not being explored yet. So we should all come together and make a plan to make a mission to explore how life is living on our own planet in these extreme conditions. So that is one of the reasons why we came together to do that. And these are some of the areas that we are focusing on, like I mentioned. So whether it is understanding microgravity, what is microgravity? Microgravity is the very, very less gravity environment when you go into space. As you move away from the Earth, the gravitational force, right now we're all sitting and talking to each other. We're sitting on our chair, and we are able to sit because the Earth is pulling us down. It is holding us down when we're standing. But as soon as you go into space, that gravity is very, very less. So it's very hard to sit down. Your body will start floating up. Okay. And what does that do to our body? Like inside our body, all our organs, our heart, liver, stomach, they will all start feeling, there is no force holding them down. So gravity affects our body, it affects our thinking, it affects so many different things. And we want to study that, right? So I mentioned to you at the start, in the middle of my talk, where I was conducting some experiments. We want to continue doing that work. We want to look at lunar and planetary. So we want to look at the moon, we want to look at Mars and other locations. And lastly, we want to look at the different extreme places, on our own planet. And as part of this, I've gathered a team of people who are coming together to explore these different conditions together. And I've managed to find experts who have worked on all the continents in our planet, who have worked in Antarctica, who have worked in Africa, in Australia, in Asia, and in India. Since 2016, we have been conducting this kind of work. And these are scientists who work in these harsh conditions, whether it is in the underwater, whether it is in the rocky deserts, whether it is in these very snowy conditions, very harsh winter conditions, or alongside the lakes that are having a lot of these salty conditions for life to live. So we have brought people from all these different backgrounds together. And we are working very closely now with ISRO. The Indian Space Research Organization has given us a small project to work on the microgravity report for them, to understand what kind of missions can be developed to send to the space station. And we are also working very closely with the Ladakh government. So I mentioned Ladakh to you. This is a location in the Himalayas where you have these conditions which are similar to early Mars. It's a high altitude, very mountainous terrain, very cold, dry terrain. So we work there. And we have an upcoming expedition there where we will be going again after 9 years. We have been doing a lot of expeditions in the middle, but Spaceward Bound is an expedition that we had conducted for the first time in 2016. So many of you might have not even been born there who are on this call today. We had conducted this expedition for the first time, and we are planning to go back again to conduct the next version of that expedition. And these missions involve a lot of different kinds of testing. You can see this photograph on the bottom right side. You have scientists who bring different instruments where you're trying to sense the temperature, the wind conditions, and you're capturing all of that data. And those instruments are going to be used to go to Mars to capture all the environmental data there. So before you send it to Mars, we actually take it to places like Ladakh in India, which are similar conditions to Mars, so that you can check whether that instrument is working or not. Okay. The other area where it helps us is, you can see in this photograph on the left side, this dust devil is forming. Sometimes you might have seen these wind, almost like tornadoes that are formed. They're not really tornadoes because they're not very strong, but so it's not very stormy tornado like a cyclone or anything, but these are called dust devils. So dust devils is nothing but you have this wind that picks up all the dust from the surface, and you can see this white color cone that is forming, like a funnel that is forming as the dust is kind of getting lifted up, and then it goes up and then it dies out on the top. So it all falls back down. But all of these are interesting phenomena because we see these happen on Mars as well. And potentially they might have happened on Venus as well. So you actually, when you go to these places, you get an opportunity to explore these naturally occurring phenomena, which is very hard to imagine if you're just, in a classroom to imagine, or in a lecture hall or in a lab. So these natural conditions are places where you can test different kinds of thought processes, hypotheses. We have also been training a lot of individuals, like students, who live on Mars. So there is a Mars Desert Research Station in the US, and we had trained 6 students to live inside the station. You can see here behind in this photograph, this white structure. This is a photograph. This is the part of the Mars Desert Research Station, MDRS. And these people who are standing here in the front, they were part of a team that last year was living inside this structure and training in different aspects. So you can see all these photographs here. You see that we had somebody who was training on this telescope. This is a telescope that is used, the observatory next to the station. You had somebody who is training to explore all the different rocks that are present around the station. So this is the station in the United States, and it is basically being developed to learn how humans can live on Mars. So it's like a testing place. So we want to build a similar station in Ladakh, in India, and we wanted to train the people that how do you live inside such a station? How do you design it? How do you operate it? So for that purpose, we had sent some people from India, from other countries as well, to US to train inside it. You can see over here, this is a greenhouse. So greenhouse is where you can actually grow plants, and you can see how plants are surviving. And if you had to go to Mars, live on Mars, you have to actually grow your own food. So you have to do farming. You have to do small amount of food production. So how do you do that? Can you use the soil on Mars to grow anything? Because you cannot carry soil from Earth, right? It is very, very heavy. So you have to use the soil on Mars. So we were using the soil that was present in that environment to grow certain things. And we were, inside this greenhouse, you were able to create the right temperature requirements, humidity requirements to grow things. And, all these are different spaces inside the station for used to train people. So these are opportunities that all of you can take to go and understand how does a human live on another planet? What are the different things they can do while they're there? So this year we are having our expedition. We are going to be announcing the team very soon in the next few weeks. So definitely you should all watch out for that. We have a very exciting number of people from different countries who have come together to be part of this expedition, and we will be announcing the team very, very soon. So Spacebound India is taking place in Ladakh in 2025, and our objective is to set up a station that looks like this dome structure that you're seeing here in this photograph. And there will be people who will be exploring and studying this terrain as you're seeing in this photo. This is a photo that is just for for an understanding. It's not a real photograph, but this is what it will look like in that environment, in that terrain. You can see all these mountains in the background. You can see these valleys, and it's completely dry outside this environment. There are no trees that grow. It is at such a high altitude that it is above the tree line. So because it's above a certain height, trees don't have enough oxygen or nutrients inside the soil to grow. So the only thing that grows are like small shrubs and little weed on the side. That's about it. But other than that, it's a completely barren environment. And all these white patches that you're seeing on the side of the lake are actually salt deposits. Because over time, this lake, it used to be a very, very full lake. It used to come up till, almost till here. But you can see here in the photograph, there are these people who are walking close to the lake. It's because the lake is completely drying up and there is no rainfall there. Like here in Sri Lanka and other parts of India, you have a lot of rainfall. So the water comes and fills up the lakes. But at such altitude, the rainfall does not reach there. The clouds do not reach there. So all the water that is there inside the lake is actually coming from the snowy peaks, and it is glaciers that are slowly melting. And over time, those glaciers are also melting now. There is very little ice remaining in the Himalayas, and it is a concern for all of us actually that we don't have enough ice there. But that's a different topic for us to conserve our own planet. But basically on Mars, many, many billions of years ago, Mars was like Earth. It had water on its surface. And today there is no water. It is completely dried up planet. So we want to study what happened. How did Mars become completely dry? So we go to places like this in Ladakh, where we try to study and understand how this environment is changing, So that's something that I just wanted to describe to all of you, that why these kind of places are important for us to go to be able to understand. And scientists, there are different kinds of experiments. As you can see on this activity, list, you have people who are biologists who are trying to study the microbes that are living on the shorelines of the lake. And these microbes are very tough, hardy microbes. They can live in very, very harsh conditions. They're very different from the microbes that you will have, in your gardens or your lakes inside, your close to your places. These are living in very, very tough conditions because there is very little oxygen. There's very little water. It's a very salty conditions. So they have evolved over thousands of years, hundreds and thousands of years, to live in that kind of a condition. Similarly, there are teams of people who are interested in testing rovers. Like I mentioned, I showed you some photographs of rovers as well at the start of the talk. So there are teams that are going there to test rovers in that kind of an environment. There are teams that are collecting environmental data. And we also have human-centric studies where we are actually going to be sending some people who are what we call analog astronauts. So astronauts are people who go into space, but these are analog astronauts, which means that they are not going into space yet, but they are going to these extreme conditions on our planet where they have to help conduct certain experiments, and they are also part of the experiment. So they will be wearing some sensors on their body where we'll be looking at how they are performing in this kind of extreme conditions. So these kind of human performance tests, biomedical tests, we'll be conducting there. So eventually, this is just to give you like a large view of what the station will look like. You have this station on one side. It will have some space for people to live inside it. An engineering area will also be there. There'll be some training area where they'll be conducting some training before they go out. There'll be a science lab where they'll be conducting some scientific experiments. and you'll have individuals who are wearing like this suit and like a backpack and going outside and simulating like what it will be like when they go outside the habitat on the moon or habitat on Mars, and they can conduct these kind of experiments. And these are the different locations, science sites 1, 2 and 3, that the team is going to be exploring while they are living there inside that habitat. And on the bottom here, you are seeing mission control, which is basically going to be located at a far off location in the city, where the rest of the larger team is able to communicate with this team that is there in this remote environment. So all of this, what you're seeing here, is set up to support how we can how can we conduct missions with humans that go to other planets. So it's a human mission training that we are kind of planning to conduct, and we are working with different team members in this whole thing. So this is basically just a summary of that. The dates of the expedition: the first expedition will be from 18th to 27th of July, and we plan to have more and more expeditions. So in case if there is a team of university students that is interested to come from Sri Lanka, maybe we can find out a way in which we can make that happen and give them that experience together to work in that kind of conditions. These are just some photographs of some tests that were conducted. You can see here, this was about 3 years ago, where this is in Sokar, that lake that I showed you in Ladakh. It's completely dried up. It's a dried lake bed. And there are students here who have built this rover, and they are testing it on the surface and checking how the rover is able to run and perform its experiments. Similarly, there are these people who are standing around this red box here. So this is a ground penetrating radar. So what it does is it sends down some electric signals into the surface underground, and the soil beneath is completely frozen. It is having ice layers. And similarly on Mars, you have the same ice layers, underground ice layers, which are called permafrost. So we are trying to understand how much that ice is, how deep it is. So this instrument is used to study that. And these are some old photos from the other slides that I showed you of people, walking around, exploring the terrain. So our objective is to provide this training to students, to scientists, engineers, and train them for the space exploration. We are also working with some artists. So another thing that we would like to do is we would like to create some interesting, unique posters to capture the imagination of the general public. And what does it mean to explore these unique environments on our own planet? So here we collaborated with an artist in India, Mumbai, called Pratik Arora, and he helped us build these different posters that captures the imagination of people on Earth that are interested to go and explore space or go to these extreme environments. So you can see here this protagonist, this male or female person, is looking at different objects on our planet, and he's trying to imagine space. He's trying to imagine what it is like to go there and explore it, whether it is in Ladakh or standing here next to I think probably a tomb, Mughal period tomb, and then on the right side here in a lake, in a large crater lake, which is almost shining like a radioactive lake. So these are obviously like not real images. It is like a fiction, but it helps us make it appealing to people so that they're able to also get captured into why we are doing it. Another last thing that we have done is we have been working very closely with SETI. So SETI is the organization in US called Search of Extraterrestrial Intelligence, and our objective is to work with them to set up a node in India. And last year in December, we actually conducted a workshop in Goa where we brought about 12 experts from all different institutions in the country to discuss what it takes to develop like a program, a SETI-based program in the country. So this was another activity that as Protoplanet, what we do is we not just train the people, but we also bring people together, develop the scientific agendas for the meetings, and train them together. I think this was my last slide, so I'll stop here. And thank you so much for the opportunity.
Thank you very much, Siddharth, for a very informative and very interesting lecture to have with us, our students. And now we are going to start in our Q&A sessions. Dear students, if you have any questions regarding today's amazing sessions, and make sure to raise your hand, then one by one, then I can just call your name. And also, Siddharth, I would like to ask in a couple of questions regarding if anyone interested to become an astrobiologist or sort of
Yeah,
like in that similar field. What are the
sure.
opportunities in India? Because of India is one of the closest countries to the
Yeah,
Sri Lanka. I know there are a lot of impressive landscape are available to train as an analog astronaut. So,
yeah,
as I said, like, what are the opportunities to get for the
yeah.
undergraduates and the
Sure, sure. I think if somebody wants to work in this field of astrobiology, which is if you are interested to search for aliens, search for sign of life outside of Earth, you need to there are several ways in which you can get into this. After one is keep yourself constantly engaged and inspired as you're going through your school education, and choose the study of your choice, subject of your choice. So whether it is in science, whether it is in engineering, and in science, whether it is in biology or physics or chemistry, the first thing that you should do is you should train to enroll yourself in the university and with the subject of your choice. So there is not one particular course or program that you need to do at the undergraduate level. So after you've finished your schooling, your 11th and 12th standard, you have to go to college. So you should choose the college of your subject and college of your choice. And you can do that in Sri Lanka as well. After you have conducted, you have finished your studies in undergraduate, and even during undergraduate, you will find there are a lot of opportunities that are there. Like there's an organization that I'm part of called Blue Marble Space, where we give a lot of internship opportunities. So this year I have 3 students who are working with me in the summer, and they are developing some biology projects with me. And they come from various countries, Bolivia, Ecuador, Peru, Chile, and India. So I work with students from different parts. So they're all doing their, one is a geology student, one is a biology student, somebody is a geophysics student. So they come with different backgrounds. Okay. So you can all choose whichever subject you like, and you can get into that. After you've finished that, once you're choosing to do, you have to study and do research in this topic. So you have to take up a master's program. When we had started this program at Amity University in Mumbai, we were the first university to have an astrobiology and space science master's program. So you can choose that, or you can choose other masters as well in your own field. And while you're choosing that subject, you can do the research work in the astrobiology topics. So you can choose to do a summer internship, or you can choose to do a thesis project. So as you're slowly growing into your field, as you're getting more and more knowledge, you'll be able to find your path. And today you have so many opportunities that are there. Different design competitions are there, conferences are there, workshops are there. So you should always try to learn as much as possible and go after these opportunities.
Thank you very much, Siddharth. And so, what is your best inspirations to become an astrobiologist and follow in such a discipline?
Yeah, I think earlier the interest was I wanted to become an astronaut to go into space. I think I still have that ambition, but when I started, it was only that. The interest was that I want to learn how do you become an astronaut and go into space. So I was very inspired by Kalpana Chawla. She was an Indian astronaut who who was part of NASA, and unfortunately, her mission did not end very well, and she lost her life. And I was a student that time. I was 13, 14 years old, and I was very inspired by her. And I used to keep reading about her as much as I liked, and I wanted to go to NASA and work and get that experience. And I got that opportunity to go there and learn. And in fact, I got a chance to also speak with her former husband who was working there. So it was a very life-changing moment for me to get an opportunity to speak with her and understand, not with her, with her husband, and understand what it is like to do that. And then after that, I also followed a lot of other scientists at NASA, people like Chris McKay. He's a scientist who's working at NASA for last 30 years, 35, 40 years. and they're all, they dedicate their entire life to these missions. So that was very inspiring for me. And I think all of you should look for people who are very, very passionate and very serious about doing these kind of studies as well, because these topics are going to help not just, our country, but it'll help the humanity. It'll help everybody on this planet.
Thank you, Dr. Siddharth. Dear students, now it's your time. If you have any further more question, make sure to raise your hand because this is the best opportunity. Today we have a very special person who have excellent experience who taking with the many of space agencies in worldwide. Yes, I notice Reshma. Go ahead. You can ask your question.
Sorry, sir. How do you get an internship?
Yes. So, is this for students, like for school or for university? I'll tell you accordingly.
For university.
University? Okay. So normally that depends on the organization. So I'm part of Blue Marble Space. Blue Marble Space each year announces a program called Young Scientist Program, YSP. So this year's program has just closed. We have just started the batch of internships. So each year around early part of the year. So I think for next year, you should watch out for announcements in late 2025, early 2026. And you have to apply, like students have to apply individually for it, and they have to submit letters of recommendation, and based on their application, they will get selected for an internship. And most of these internships are online. So they are virtual internships, but it's a great opportunity because you get to work on topics with some very, very experienced scientists, on topics. So that is as far as Blue Marble Space is concerned. They have a young scientist program. Other than that, a lot of institutes have their own programs. We at Protoplanet don't currently have a formal program for internships. Whenever we have a requirement of students, we reach out and then we find some students. But from next year onwards, we will plan to structure that a little bit more. There will be a lot of opportunities to participate in expeditions and be part of experiments and missions for sure. But as far as a formal internship is concerned, next year is probably when we will announce it, like similar to like the Blue Marble program, where university students can work with us on certain topics.
Okay, great. Thank you.
Thank you.
Okay, thank you, Siddharth. And is there any other questions, dear students?
Hi, sir. I am Hasuddin Sara. According to your opinion, can a suitable environment for living a harmony with nature be created?
That's a very interesting question. I think yes. If you look at life in the forest, they all coexist with each other. But as humans, I think we have forgotten how to live in harmony with the nature. And when we put ourselves outside of the cities, if we put ourselves in these natural conditions, we are like aliens because we don't belong there anymore. So how do we live with the harmony? That's a very, very, I think it's a very nice point you have raised there. And I think it requires a very good understanding of nature. We need to understand, because nature is very complex. Forests are very, very complex. You cannot just cut a tree and then cut as many trees and live there and expect that, it affects the whole chain of the birds, the insects, animals, everything. So even for us, when we are going into these very remote places, it is important for us to understand what is the nature there like, which are the plants, which are the microorganisms, which are the endangered species that are there, and how are we creating waste there? Because as humans, we all create waste, solid, liquid waste. How are we managing that? Where are we putting that waste? And are we harming our environment? Are we creating any conditions that are harming? So to answer your question, it's a very good point that we have to constantly find ways to understand the environment firstly, understand the nature, and we have to, after we have understood it, we have to find ways to create the right conditions where we are minimizing our impact, reducing our impact in that place. So it is something which is very important and not many people do it. So we have to be very careful. That is why when we are trying to go into space, we have to make sure that it is not at the cost of harming our own planet, So I thank you for that question. I think it's a very enlightening thing for me to realize that we have to be in the harmony of wherever we are living.
Thank you, sir.
Thank you very much for the Siddharth to answering each every question. So, dear students, I'm going to wind up today's session. I think like today is a very special day for us. After 3 years later, again, we have a very interesting discussions with one of our glorious scientists, Dr. Siddharth Pandey, because of his motivations and his inspirations are really supportive to the most of Sri Lankan students. Because of he's one of the pioneer scientists in India who lead in the astrobiology outreach and educational awareness. And today, on behalf of the Eco Astronomy Inc, I would like to pass my gratitude and to our Dr. Pandey to join us and sharing his thoughts with our students. And this will be really helpful to most of Sri Lankan students to step forward with their future career. And again, thank you very much, Siddharth, and we hope to engage with you in the future, and we hope to have any further update. And please let us know. Then I hope, like in the future, some of Sri Lankan students also participating with one of your analog missions. Thank you very much again, and have a great day.
Thank you. Thank you so much, Arvind. Thank you for the opportunity. Take care, everybody. Bye-bye.